Use Lagrange multipliers to find the maximum and minimum values of f subject to the given constraints. F of x, y, z equals x squared plus 2y squared plus 3z squared. X plus y plus z equals 1. And x minus y plus 2z equals 2. Lagrange multipliers, setting up the system of equations when we use Lagrange multipliers shouldn't be too difficult. Solving the equations, hopefully the problem is structured such that the equations are not too difficult. But I think this will mostly just turn into crunching through the algebra. I suppose we'll have to be wary of whether we're finding minima or maxima during all of these computations. And given that we have two constraints, we know we're going to have two Lagrange multipliers. That might make solving the equations a little bit more difficult, but I don't really see exactly what the process is going to be until I start working through it. But I'm going to set up the equations and see what happens. Okay, so this is the information we're given. The thing that we will end up taking partial derivatives of as I introduce the Lagrange multipliers will be the following. So these three equations have to be satisfied as well. Both of these quantities in parentheses have to be equal to 0. That's 5 equations and 5 unknowns. What might be the easiest way to do this? I mean, I see right away in the structure of these equations, I can add these two together, and that'll cancel out the thetas. I'm just going to try and solve for x, y, and z by working with these things, doing some algebra. I don't really have a well thought out process for this, but I'm just going to manipulate these equations and see what I can get. Okay, starting with the three equations corresponding to partial derivatives, I just manipulated them to eliminate the lambdas and the thetas by adding and subtracting them in various multiples. And I end up with this equation for x, y, and z. But if I also bring in these two quantities, these both have to be equal to 0, this is going to give me two more equations. So I will have 3 variables and 3 unknowns. Should be able to solve. I'm just going back now to check my algebra. I ended up with z is equal to 11 over 23. I want to make sure that I don't have a little arithmetic mistake where this should be something like 11 over 22, which would be make things a lot simpler. Yeah, this is what I end up getting. So it's not the nicest looking coefficient, but that's all right. So let's substitute this back into some other equations and see what we get. Okay, so I have my values of x, y, and z. I should hopefully just be able to compute what the value of the function is now. Won't be very messy with the coefficients we're given. Okay, I don't know if there's an easy way to do this arithmetic easily. I'm just going to use a calculator and see what number we get here. Okay, this is what I get for the value of the function at this one point. And by looking at the function itself, this has got to be a minimum of the function along with constraints. So the two constraints themselves both correspond to planes in three-dimensional space. When you intersect two planes in three-dimensional space, you get a straight line. So this is a line that extends infinitely in both directions through space. And because of the form of the function, x squared plus 2y squared plus 3z squared, we can make that as large as we want by traveling infinitely far in one direction across along a line. And so this function is unbounded from above. meaning, if it's bounded below, then on this line, it has to achieve some minimum value. So this will be a minimum. The function will not have a maximum on the constraint. All of this is, assuming I didn't make any simple arithmetic mistakes in solving for x, y, and z. I checked my work a couple times, so I don't think I did. If I wanted to be absolutely sure about something like this, I might even check it numerically. But I'm confident in the process, mostly confident in the algebra that I did in the arithmetic. If I find a mistake in this, I'll put it down in the description, or if I have anything else to say, I'll put it down there. Otherwise, thanks for watching.